Okay, so in the yesterday session, we talked about TLS, why TLS is required, TLS handshaking, etc. Right? So today we will also see that practically, but before that, let's understand other types of concepts available. Okay, so here we have various TLS or SSL certificate types. Okay, so you have single domain SSL certificates where the certificate is issued just to a single domain. Okay, if you see www.google.com is the domain name. Okay, so this is a single domain, you can get a certificate for this domain. Okay, and also if you get a certificate for this domain, so whatever paths that you use in the URL, let's say this is the certificate, this is a DNS name for which you got the certificate. You can use any path like this, like slash gmail slash youtube slash. So all these paths are also covered under the same certificate. Okay, so that is called single domain. Okay, so you have wildcard SSL certificates. So this is most common and popular certificate types. What is this wildcard certificate type is? So this certificate type, supports multiple domains. Okay, so if you take google.com is one domain, so its subdomain is gmail.google.com. Okay, if you replace this with youtube.google.com, so this is another DNS. So here this is the domain name, and you can call this as the subdomain. So here the certificate is issued to wildcard, that is asterisk dot google.com. Okay, so which means this asterisk can replace anything like gmail, drive, sheets.google.com. A single certificate now will cover all these domains, which means all these domains are covered under the certificate. So you'll get HTTPS communication. Okay, understood guys? So there are other types as well, but we will not talk about them. So you can just Google and understand what are the other certificate types. Okay, so the question is, how do you get a certificate? Okay, so we know that the certificate has to be signed by the root CA, which signs your public certificate with the private key of the CA, right? Correct? So CA will sign
Yes.
it with its own private key. Okay, so how do you get a certificate? So for sure, you need to send your public key, but how do you send that public key? Okay, so you cannot directly send a public key like that. Instead, we rely on one more object known as certificate signing request, CSR. Okay, so CSR is a request to the CA to sign your certificate. Okay, as expected, this CSR certificate signing request obviously will contain your public key of the domain. Okay, so why CSR is required? Why can't I directly send the public key to the CA to sign it? Okay, the reason is CA needs a lot of information like your name or your state, location. Okay, the domain name for which you want the SSL certificate. Okay, the country, the area, your email address. So it needs a lot of information. Since I cannot send them separately. Okay, so there is a standard method of obtaining a certificate. It is through a CSR. Okay, so one CSR, that is the request, is sent to the CA. Now CA will read it. First it will authenticate you. That means it will also check whether the domain is actually owned by you or not. Then it will check for some other information, then only it will give you a certificate. Okay, so we'll see the contents of CSR in a bit, but the most included, the commonly included information is the domain for which you wanted to get the certificate, your organization name, country, locality, email, and obviously the public key. Okay, clear? And of course you should not share your private key, so private key it should be you. Okay, so your CA doesn't require your private key, it only requires your public key. Okay, and you should keep your private key safe, because if you lose it, your certificate won't have any value. Clear? Understood guys? So as we already know, CA will not issue certificates randomly. It has to do a lot of verification. So first it checks whether the domain belongs to you or owned by you or not. That is what the first step, or it can be one of the steps. Okay, so if you go to this whois.com, okay, So here I can find out, basically who owns a particular domain. Okay, let's say that, so I'll just visit this website and then I'll enter the domain name. Okay, so let's say amazon.in. I want to know who owns this. Okay, you can see here registrar is this. It is going to expire on this date. So it is registered on 25. Okay, this is the domain name. You can also see the country, state, the organization that requested for the certificate. Okay, so here email address is hidden for security reason. Okay, so this is all I can search. In fact, let me see if I can get my website information. Okay, so DevOpsMadeEasy.in. Okay, so this is a registrar, some registrar. Okay, so if you see, this is what, so this is my current location, but here all the details of the email addresses are hidden. Okay, I bought this certificate for 3 years and it is going to expire next year. Okay, so by this date I should request for certificate renewal. Got it? Understood, guys? So this is how you check, basically who owns this domain. So this is the first check. Okay, your CAs might even send an email. Okay, because your email address is included in the certificate signing request, they might email you to see whether it is you who actually requested for the certificate. They might even search for the government databases to see if your organization is registered. Okay, they might even ask you for the organization certificate. Okay, so there are many verifications that are done before issuing a certificate. Okay, so you will not get a certificate that easily. Okay, now let's understand how to create a CSR. Okay, what is the actual process? Okay, so first process is you start with generating a private key and a CSR. Okay, so why there is no public key here? Because that public key is already there in the certificate signing request. Then what you will do, you will send this certificate signing request to the certificate authorities like Komodo, DigiCert, GoDaddy, okay, Symantec, right? Global Sign. There are a lot of them. Okay, so how do you generate this CSR? So you can generate with tools such as OpenSSL, or these CAs. They often provide you scripts and other, automation tools to automatically generate the CSR for you. Okay, so anyways, once you generate the CSR, you should send it to CA. Now what CA will do? CA will read your information, that is the certificate signing request. It will have your domain name, the public key, your email address, country, area, every information is available. So once it validates, it signs your CSR with its own private key, and it will issue a certificate for you for your domain. Now what you have to do, you have to take that certificate. Now you have your private key with you, and then you have the CRT, which is the certificate. The certificate signing request is not needed. Okay, so next time when you want to send the renewal request, then you might require it. But for now, you have the private key and the certificate will have the public key. Okay, so your certificate and private key, you should configure it on your web server, so that anyone now who tries to access your web server will now get HTTPS communication. Okay, because once you have the certificate installed in your server, okay, if I try to connect your web server, I'll get a certificate, that is your domain certificate. Now this domain certificate is validated by the browser, because browser will have CAs all certificates or the public keys. So once your certificate is validated by the browser that your domain is actually signed by the trusted CA, then what will happen? Your browser will share a shared session key with the server. Now both server and client will talk over HTTPS. Clear, guys? Understood? So this is the only method. Any questions, guys?
No, Vikram.
Okay. So there is one more concept that we need to know, it is just a field inside a certificate signing request. Okay. So certificate signing request obviously will have the domain name. So we call it as a common name. Okay, so this is the name or the field that we use in CSR that indicates your domain name. Let's say Amazon.in. Okay, so this is called as the a common name, but this common name field is slowly being replaced with something known as subject name alternative, also known as SAN. Okay, so if your certificate, okay, if your certificate as the common name field, but if it is not including the SAN field, your browsers will not accept it. Okay, so your Chrome browsers and all made it mandatory that your common name and certificate your subject alternate name both should be available. Okay, so what is this subject alternative name? Okay, so it is very easy. If I say common name as www.amazon.in, okay, um, subject name alternative, so as the name itself indicate, it is an alternate names to this domain. Okay, instead of calling amazon.in, people will also use amazon.in. Okay, or simply let's say that instead of using amazon.in, I can also use something like amazon dot co dot in, something like this. Okay, if you take this as a domain, so what are the aliases, what are the other names? Okay, so that is called subject name alternative. Whatever certificate that you're getting from the certificate authority will cover all these names. The certificate is valid for all these names. Okay, in case if you have a common name which is your domain name, but if you don't have the subject name alternative, your browsers will simply throw an error saying that error certificate common name invalid, because s SAN field is absent in your certificate. Okay, so as I already said, if I take example.com as the common name of the domain name, you can have example.com, www.example.com, example.net, main.exam. These are all the alternate names for the main domain. Okay, in fact, if you try to check the details of your certificate, which I'm going to show in some time, okay, you can also see the subject name alternative, which are, these are all the names that are covered by the same certificate. So don't get confused with the wildcard certificate. This is not wildcard certificate, this is subject name alternate. What are the alias names that people will use to access your website? Okay, clear guys? So this SAN field is slowly replacing the common name field. Okay, I'll also show in the demo where to put this subject name alternative. Otherwise, you're going to get errors. Okay, and all the certificates, right? Whatever certificates that we are seeing follows X509 standards. Okay, so this is a format in which a certificate can be represented. Okay, so your certificate should have a subject, common name, subject name alternatives, its validity, the CA which issued that certificate, the size of the key, the algorithm used, the serial number of the certificate. Okay, everything is included because this should be a standard format. We have X509 certificate. Got it? Any questions? Any questions, guys? Okay, now let's see how to generate a CSR. Okay, it is very easy. Okay, so we can use OpenSSL utility. Again, I'll show you in the demo. Okay, so here OpenSSL can support creating a private key, certificate signing request, creating a certificate, everything is supported. So here what I'm saying is I'm asking it to generate, it's a request for a new key, private key called vikram.key, and also it is outputting this vikram.csr. Okay, so it creates this key and also the certificate signing request. Okay, so once you issue the certificate signing request, once it needs to create this certificate signing request, it is going to ask you for some information. Okay, your country name, state, locality, organization name, unit, common name, which is the server DNS or the FQDN, and then your email address. So once you enter all these fields, okay, it will give you your private key and also certificate signing request. You need to send it to the CA. CA will give you the certificate. Now you will have the key and whatever certificate that CS sends back to you. Okay, clear? And also I'll show you how to decode a certificate and how to decode a certificate signing request. Okay, so if you get a certificate and if you try to open it, okay, since it is a certificate, you will see all scramble letters. Okay, a certificate begins with begin certificate and end with end certificate. Okay, so everything is required, so don't just take the data in between them. Okay, so this begin certificate string and end certificate string both are required. They start with 5 hyphens, begin certificate, and closed with 5 hyphens. Okay, so this is a certificate, but if you want to decode it, again, since this is a certificate, this is an X509 format. So what I'm saying, asking this OpenSSL is to decode the certificate X509 by taking the certificate as the input and converting it into plain text format. So this is for the CRT, that is decoding certificate. If you want to decode a CSR, see here certificate is X509, but here CSR is not 509, it is a request. It is a certificate signing request. That's why it's OpenSSL request. Input is CSR. Again, it will generate the text output. Okay, got it? Clear, guys? Okay, now let's go
Yes,
to
we
the
got.
demo. Okay, so for this I already created a Git repository. Okay, if you go to this Git repository and search for TLS mastery, you'll find this readme.md file. Okay, so first thing what I'll do is I'll try to install a web server and show you uh, you know how to access it on HTTP. Then I'll show you how to create a certificate and install it. Okay, so let me I think we already have this server from yesterday. Okay, so I'll quickly install Nginx. So yum install Nginx. So this is a web server, and this will serve the index.html page as we already know. Okay, and then systemctl status nginx. Okay, so it is disabled. So what I'll do now? Hmm? What should I do now, guys?
Yes, we have to start it.
Okay, so it is enable hyphen hyphen now. Okay, so I started it, and understand that nginx serves all the HTML files under user share nginx under HTML. Okay, so if you see, it is going to serve this index.html page, and nginx has all its configuration under etc nginx. Okay, so there is this config file called nginx.conf. Okay, this is where nginx stores all the default configuration. Okay, now since I already installed web server, okay, so let me log in into my Amazon account, because we need to open the port 80. Okay, able to see my screen, guys? Okay,
Yeah, we
so the
can.
instances. Okay, so let me go to the security, go to security groups, and here edit inbound rule and just add 80. Okay, IPv4 save rules. Let's take the public IP address. Okay, and then 80. Okay, so here you will have the nginx file, HTML file, but you can see here this is not secure. Your site is not secure. Okay, and here if you see, there are no certificates. Okay, so what we will do is we will try to create first self-signed certificate. Okay, clear? Because we don't have any certificate authority, that's why we are not going for certificate signing request. So what we will do is we will create self-signed certificate. So what is self-signed certificate? Hmm?
or
So we can sign it
instead
with
of
our private
browser
key.
having, yeah.
Okay, if I have public plus private key, okay, if I sign my public key with my own private key, I can get self-signed certificate, right?
Yes.
Correct? That is self-signed, which means here I am giving a certificate myself. Okay, I'm signing my own request with my own key. Okay, now let's see how to do that. Okay, so we have OpenSSL. Okay, so using OpenSSL, we can create certificate signing request, private keys. Okay, and also your what do you say, CSRs. Okay, and also OpenSSL can directly give you. Okay, so actually the method is to the standard procedure is to first create a private key. Okay, and then create the CSR, and then only send the CSR to the CA. Okay, see here I don't need CSR because I'm not sending it to anyone. Okay, in fact, even if it is a self-signed certificate, what I can do is I can first create a private key and then create a CSR and get my CSR signed with private key so that I'll get the certificate. Okay, so OpenSSL can do from step 1 to 3 in a single command. Okay, otherwise what I have to do, I have to use separate command for private key, separate command for CSR, and for signing again I need to it's third command. Okay, I don't need that. Okay, so in case if it is self-signed certificate, I can directly create the private key and the certificate. So internally that CSR will be managed temporarily, so temporary CSR will be created and it is signed with the private key so that you will not see any CSR related files in your machine. Okay, so how do I do that? Okay, so first OpenSSL, it's a request, and also it is X509 because I also need CSR, and that CSR has to get signed by the private key, but I want both to happen with the same command. That's why it is both. Okay, so hyphen hyphen nodes has a special meaning in this. Okay, so ideally your private key should be protected. Okay, so once you have the private key, if anyone gets access to the private key, they can easily decode your information. That's why you know, along with storing your private key in a secure location, you can also lock it with a passphrase, a 4 digit key, password. If I don't want that, I can use hyphen hyphen node des. Okay, then for how many days I want this certificate to be valid, it is 365. I'm asking it to create a new key. RSA is the encryption algorithm, asymmetric encryption algorithm. So that is 2048, that is 2048 bits. Okay, so new key, I want the key to be named domain.key and the output should be certificate. Okay, so ideally it should be CSR, but since it is a self-signed certificate, I don't want to again create a CSR, get it signed with the private key of myself. Okay, I don't want to go through that process. If you want to go through that process, if you scroll to the bottom, I gave this extra part. Okay, so this involves first creating your private key. Okay, so here what I'm doing, OpenSSL generate RSA, output is your private key, that is domain.key, 2048 bits. Then what I'm taking, I'm creating a CSR, that's why it is a request. No DS means I don't want any passphrase. Key, this is not a new key, that's why it is just key. Whatever key that I give, I'm taking that key and new CSR. Okay, so now I have the private key, I've generated the CSR. Now what I'm doing here is I am signing my CSR with my own key so that it will give me the output. Okay, sorry, not this command, it's the other command, this one. Okay, so here private key is there, you have the CSR. If you come here, I'm creating a X509 certificate signed by my private key. The input is my CSR and the output is my CRT. And here if you see who is signing it, my own private key. is signing my CSR, the input, output is CRT, and the certificate is valid for 365 days. Okay. Let's say you don't want to create key and CSR in a separate command. So there is a single command where it generates your key as well as the CSR. That is also there. Okay. Let's say I don't want all this. I don't want to follow three commands. Okay. I want to directly create a private key and my certificate, self-signed certificate. Internally, CSR will be temporarily created and it is automatically signed, and CRT is given. So this is the last command, the same command I've given here. Okay, clear? Since this is a self-signed certificate, I don't require to see the CSR. I'm generating the key and the certificate in a single command. Okay, let's copy this command. Okay, so the reason why it is called domain.key and domain.crt is because it is basically a domain. You can also name it as server.key and server.crt. That is up to you. But don't say that user.key and user.crt because we are not creating the certificates for the user. Okay, those are client certificates. We are creating for the server or the domain. Of course, commands are same. Everything is same. Okay, and the same command I'm going to use it in Kubernetes authentication part also. Okay, clear? Now let's see. Okay, so request for the certificate, input is key. Okay, automatically that key will be created. That's why it is new key here, and the output is CRT. Now it is asking for the CSR information. So let me give the CSR information. Country name is this. Okay, state is, let's say, Karnataka, locality is BLR. Okay, organization name is anything else. Okay, let's say DevOps Made Easy is the organization unit name. It is, let's say, DevSecOps common name. Okay, so what domain certificate you want, for which domain name you wanted to have, you know uh, get the certificate. Let's say uh, mynginx.com. This is the domain I want the certificate for. Email address, you can give your own email address, something like this. Okay, now if you do ls-l. Okay, so here domain.crt and domain.key are there. CSR is not there because we did not ask it to create the CSR, but CSR information is taken for you, and automatically internally it signed it with the private key and it gave the CRT for you. Clear? Or any questions?
No, Vikram.
Okay, now these are the certificates and the keys that your server will have, so that whenever any client talks to it, it will send this certificate to them. Okay, right? That is the handshake process, correct? Now let's see how to enable SSL. Okay, so if you look carefully at the nginx default config, that is etc nginx.conf. You scroll here, the server part is listening on 80 or IPv6 80. Okay, and if you scroll to the bottom, settings for TLS, which means if the server has to communicate over the TLS, it is all commented out, but you can enable. Okay, so what we'll do is we will enable it. Okay, and then we have to disable it. So for this, what I'll do is I'll simply take the full content. Okay, I just took the full content and then let's paste it here. What I'll do is now I'll just comment out this server part that is listening on 80 and just uncomment this part where it says settings for TLS enable. And also remember, this is just a command, so you just comment it out. Okay, now the server is listening on 443 SSL or IPv6 443. If you see clearly, it is asking for the certificate and the key for you. Okay, and this is the location it is storing, etc pki nginx server.cert, and then this is the server.key. Okay, But what we generated in the form of domain.key and domain.cert, right? Correct? Okay. Now what we will do is we'll do the first step, that is we will copy this server certificate to this location. Okay. So I'm copying, or let's move it. We don't require it here. Let's move the domain.crt into this location because it is expecting that certificate in the form of server.cert. Okay, I'm just moving it. Okay, it will also rename. Okay, it says no such file or directory, so let's first create this directory. Okay, so mkdir hyphen p this, and then let's move the certificate to this location. Done. Now let's move the domain.key to the location where it is expecting that key. Okay, so it is expecting that key here. Okay, enter. Now again this uh, location is not there. Let's create it first and then move it. If you see ls-l, we moved everything into that location. Okay, and then what we have to do, we have to take this configuration and then replace the default configuration. So I'm replacing the default one, etc nginx dot conf. Okay, just paste everything. Now we have enabled TLS. Okay. Okay, now what you have to do, since the nginx configuration is changed, I need to reload nginx. Now let's see what will happen. Since this is no longer listening on 80, we may not get output here. So it should be HTTPS. But 443 port is not open. So let's quickly go to the inbound rules and open 443 also. 80, let's delete 80 or let's keep it. That's not a problem. Anyways, the server is not listening on 80. Okay, I can directly search for the HTTPS protocol. It will be selecting 443 anyways. Okay, now let's see here. See, it is throwing a warning for you. It says certificate authority invalid, but it is trying to connect over HTTPS, which means it is encrypting the traffic. But why this error is coming? The certificate that the server sent back to this browser is not certified by any CA, right? Because it is certified by you. You signed it with your own private key. Clear? Now, in order to proceed
So,
further,
Vikram,
I
like
need to go to
browser doesn't
advanced.
have
Yes,
the public key information. That's the reason it is not allowed.
yes. Okay. You can still see that it is not secure, but it is communicating over HTTPS, which means the data is getting encrypted. But the problem is the browser is not able to trust this server that is actually serving this website. That's why it is not secure. And also, if you see here, the certificate is being detected, but certificate is not valid. Okay. Now let's go back. The place where we have the certificate in this server. Okay, so this is the place where we have the certificate. Now I can decode the certificate using OpenSSL. Okay, I press the insert here. Okay, so OpenSSL, and then this is X509 certificate. The input is the location of the certificate, hyphen text hyphen no out is just to avoid displaying the public key. Okay, if you see, I just decoded the certificate using OpenSSL. You can see the certificate who issued it. Okay, if you see the subject means the information about this certificate, that is the country, state information, the email address. The common name for the certificate is my nginx. Okay, this is your certificate information. But if you see the issuer, that means who issued your certificate, it is also showing the same information, which means you issued your own certificate. Okay, clear? Right? That's why it is not able to trust. Even in fact, you can click on this certificate and see the certificate information. Okay, issued by mynginx.com, DevOps made easy, and issued to. If you see the information is also same. Okay. So this is the self-signed certificate, and if you see here in the certificate hierarchy, there is no CA. Okay, because you certified yourself, like you created the certificate yourself. Understood, guys? So these are all
Yeah.
self-signed certificates. Okay, here your browser is not trusting, but still you have the data encrypted. Okay, now let's see about how to create a CSR and how to get it signed. Okay, so before understanding that, but who is this CA? It is certificate signing authority. So we know that CA himself will have the public key and a private key, right? Correct? Okay, understood, guys.
Yeah. Yes. Okay.
And here he will also have his own certificate, right? Correct? But who issued certificate to the CA? No one, right? Because there is no other CA which can sign this CA, which means a CA, the CA's own certificate is signed by him, which means CA certificate is always self-signed by him. Okay, but that is fine because this is it. Even if it is self-signed, that certificate is already available in the browsers, so that is fine. Okay, so which means if I create a CSR and if I don't want to pay for someone to issue a certificate for me, okay, I can create my own CA, right? Okay, but who is this CA? It is simple, a person with a public and private key. That's it. Correct. I can create my own CA. Okay, then I can create server certificates or user certificates, and then I can create a CSR and send to my own CA to sign them. Getting understood? Yes,
Yeah.
because I don't want to spend money on the CA, but I can create my own CA with just private and public key, and then I can send the CSR to my own CA. My own CA can actually sign them. So that is what we are going to see. Okay, so for this, we are going to create our own certificate authority. As we all know, certificate authority is nothing but anyone with a private key and a certificate. That certificate is signed by his own private key. Okay, so the same command that we have used to create a self-signed certificate for this server, we are going to use the same thing. Okay, so here what we are doing, we are creating a certificate for 365 days. The key is called root CA and certificate is root CA. We don't have the CSR anywhere here because the CSR information is already asked when you run this command. The CSR is created and it is signed by your own private key, and that CSR will be destroyed. Okay, let's create our own CA. Okay, anyways, now it will ask for the CA information. Okay, I can actually enter everything like we did earlier, but here you can also do it in the same command itself by providing the subject line. Okay, in the subject line, anyways, while I was actually running this command, it is asking for the country name and all that stuff. So here you simply add a subject, country name, the state, location, organization unit, the common name of the CA. So here common name of the CA and doesn't have to be any DNS name or anything. It can be a name, a simple name, because we are not certifying, because this is not actually a server or a DNS of the server. Okay, you can use any name, but here I've used my own website name. Okay, now when you use this command, it won't ask for the CSR information because CSR information you already provided in the OpenSSL request itself. Now, if you enter this, it will directly create a root certificate and a root key. So this is the actual CA. Of course, a trusted CA, public CA will not give you its CRT or the key, because key is something which it uses to sign other certificates. Obviously, they won't give it. Okay. Now I've created my own CA certificate and the key. Okay. Let's assume that CA is a trusted CA. So whatever CSR that you send, you can send it to this CA. Instead of sending it to the public CA. Okay. Now my my CA is ready, and then you can decode the certificate. Okay, so you will see all that information that we added in the CSR: country, state, location, everything. Okay, so I just decoded the certificate. Now I have the CSR. Again, I'll start with creating my own server certificates. That means the server private key and then its certificate. But here it is not self-signed certificate, because what we will do here is, now we have the CA with us. Okay, because we have created this CA dot key and CA dot cert. So all the future certificate signing requests are to be signed by this CA only. Okay, so in case if I want to create a domain certificates for, let's say, amazon.in, so what I'll do, I'll create a private key. Okay, and then what I'll generate, guys, I'll generate a certificate
Yes, sir.
signing request. Then the CSR has to go to the CA. So the CSR is signed with the CA's key, and then they will send you your certificate back. Now this public and certificate you will configure it in your Nginx. Okay, clear? Since I am the owner of the CA key and cert, I can myself sign it. Okay, if it is a public CA, again he will verify and do all that. Okay, so first thing is I'm creating this server certificate again, that is OpenSSL generate RSA. Output is my key. Remember, here I'm not generating my certificate, that is self-signed certificate. Okay, and my domain.key is now created. Now what I'll do, I will create a certificate signing request. Okay, so certificate signing request can be done in two ways. Okay, so you can use subject line like this, or else you can also use a configuration. Okay, so I can use a configuration like this. Okay, so the content is this. Okay, so the request, how many bits you need, 2048, the algorithm SHA MD. Okay, and then here requested name, the country name, state, Bangalore, I mean location, your organization unit, and the common name. Okay, this is the part of the request. Then I also need subject name alternatives, as I already said. So these are called extensions, request extensions. Okay, here the subject name alternative, instead of putting everything here, I have defined separately. That's why I have used this placeholder, a pointer at the rate of alternate names. So alternate names. Okay, so alternate names can be other DNS names, or it can be IP addresses. So what I did is I used this as a common name, and subject and alternatives can be test dot and mynginx or mynginx.com, www.nginx.com, and it can be a simple IP address as well. Got it? Understood, guys? Okay, so what I'll do is I'll simply create the csr.conf like this. Okay, ls-l. So this is the CSR configuration. Okay, and then I can VI into CSR configuration to see every information. Okay, so here IP is the IP of this server. Okay, if you see, I'm able to access Nginx over the IP address, and also sometimes I'll also access on the DNS name. Of course, I don't have the DNS. Okay, that's why I'm using DNS and the IP address as well, like this. Okay, Now this is the certificate signing request. So what I will do, I'll take this certificate signing request to the CA, then CA has to sign it with its own private key. Okay, so for this I already have the command. Okay, so here let's assume you send the CSR. Now the CSR, okay, sorry, CSR is not created, we just created the configuration. Now what we have to do, you have to create the CSR, that is output is CSR, input is your own private key. Okay, and also CSR configuration you need to provide. So this will generate your own CSR. Okay, so it will take the certificate signing request. Okay, so now how to decode the CSR, it is again OpenSSL. Let me show the CSR first. It is domain.csr. So this is the file that you need to send to the CA. Okay, so if you have to see the contents of the CA, okay, so OpenSSL request, the input is the domain.csr and hyphen text. So text is the output. You can see the CSR certificate request. This is the subject. This is the domain which you wanted to get the certificate. If you scroll down, your subject alternative name should also be there here. Then only your certificate is valid. Okay, so now you have the CSR. You send the CSR to the CA, then they will sign it with their own private key and they'll send the certificate back. Since I own the certificate authority, what I will do is I'll take that input CSR, use my certificate and the key information to sign it, and then output the CRT, then sign it for 365 days. Okay, so now what CSR will do, CSR will internally run this command and they will give the certificate. Since I am the CA, I'm doing it in the same machine. Okay, you can see here certificate signing request is okay, and then I have the domain.crt, which means I got the certificate back. Okay, now try to decode the certificate. Now it is OpenSSL X509 because the input is the certificate. The input is domain.crt. Okay, and then hyphen text and no out. Okay, so this is the certificate serial number, certificate algorithm, issuer. Who issued this certificate? It is the CA. That's why all the CA subject related information is here. And it is issued to whom? It is issued to test.nginx.com, issued by DevOpsMadeEasy. Okay, and if you scroll here, you don't have the subject name alternative here. Okay, even though I have this certificate, it is invalid. Your browser is going to throw an error because there is no, in the CSR I was able to see that subject name alternative, but once I created the certificate, that SAN fields are missing, subject name alternative. So this is the issue with the OpenSSL. Okay, so OpenSSL, try to strip off all those extensions. Okay, so if you see here in the CSR config, we are saying these are all the extensions, that is SAN fields. Those are ignored by OpenSSL. Okay, then again what I have to do is basically I need to include those extensions, okay, by creating another file called v3.ext. Okay, and all the extensions that I defined earlier, I have to use those subject name alternative. Then when I'm creating the signing the CSR with my root key and the certificate, I should also use the extension file. Then my subject name alternative, which is available in the extension file, will also be taken. Now my certificate will also have the SAN field. Since this is extra work, what we can do is in the same CSR config, okay, I can use the v3 extensions. Okay, so I can use the v3 extensions. Okay, so here subject name alternatives is again pointing to @alt names. That means this is @alt names. Okay, and now when I'm generating the CSR, I will give the CSR config while generating the certificate. Okay, so once I create the CSR and send it to the CA will sign it with own certificate and the key by taking the input as my CSR. Now I can also use the extensions. Okay, so what is the extensions? It is v3 underscore ext. And what is this extension file? It is nothing but the csr.conf file. Okay, so once this is done, I can also see that SAN fields in the certificate. So for this, what we will do is we will again replace the CSR config with our new config. Okay, and remember to change the IP address with actual server IP address. Now CSR is modified. What I'll do is I'll take my own private key and generate a new CSR with the above configuration again. Okay, and then once I send it to CA, it will sign it. Since I have the CA with me, I'm only signing it. Okay, it is signed. Now if I try to view the certificate information, okay, domain.crt, okay, I'll be able to see the subject name alternatives in the certificate. Earlier, when OpenSSL ignored those extension, it also ignored the SAN fields. Okay, now we have the subject name alternatives also. Okay, right? I have created now domain.crt and key. This domain.crt is now certified, or the certificate is issued by this root CA. Okay, again what I have to do, I have to configure this new certificate. Okay, so we know how to do it, right? I need to move the domain.crt into server.crt. Okay, like this. Of course it will ask to override. I will override the old certificate, and then again the domain.key will also override the server.key, because Nginx expects the names to the server.crt and server.key. And then let me restart. So systemctl restart Nginx. Okay, here, as we already know, we have used these domain names. Okay, so what I can do is I can create dummy DNS entries in my Windows. Okay, so for this, let me open Notepad++ in the administrator mode, and then we need to open the etcos file. Okay, go to file, new. Sorry, go to file, open. So it should be in the C drive, Windows, System32, uh, drivers, etc host. Okay, so what I'll do is I'll add the server IP address. Okay, because server IP address is should be mapped to the DNS, right? Okay, so this is the IP address of the Nginx web server. And then what all the DNSs we have used in the certificate signing request? Hmm? Tell me, guys. It is Nginx, test Nginx, www.nginx, and that IP address. IP address is not needed. Okay, so multiple DNS entries can be separated like this. Okay, instead of creating IP and this DNS, again IP this DNS, IP this DNS, I can use like this. So save this host file, open CMD, and then type ipconfig by flush DNS. So this will delete all the DNS cache, so that a fresh DNS will be loaded. Okay, now I can take any of this mynginx.com. Okay, since this mynginx.com is resolving to the nginx IP address. Okay, it will see like, but here again, even though it is signed by the CA, it is still showing me this. Okay, if I click on this not secure and click on the certificate, you can see clearly issued to nginx.com server, issued by DevOpsMadeEasy.in, which means some other CA issued it. Okay, it's a CA, it is not self-signed, but that CA's public certificate is not available in the browser. If you go to these settings, privacy and security, and security, go to this manage device certificates, trusted root certificates, I don't have my CAS certificate here. That's why it is not showing, not verified. So for this, what I have to do is, I will take my root certificate. Excuse me. I'll take my root certificate, copy the content here, just save it somewhere in your machine where your browser is running. Just save it with some name. Okay, so I'm saying use all types. Let's say my CA, or let's say DMACA dot CRT. So this is a certificate. Always remember CRT should be there. Now what I'll do is I will add my certificate. Okay, because I created my own CA. That CA's root a public certificate should be available here. Click on import. Next, just use the file. Next, add it. So once you add it, if you scroll to the list of CAs, now you can see that my CA is already added in this browser. Ideally, within your organizations, all these browsers are managed by the IT team. Okay, if they have their internal CA, those internal CA certificates are already added into the browsers. Okay, you don't have to manually add them. Since my root CA's certificate is already added, so that the browser can validate the incoming certificate that is signed by my CA. If you refresh this page, second, it is still loading. Okay, if you see here, there is this padlock. Connection is secure. See here, if you click on this certificate, it is perfectly trusted. MyNginx.com is the DNS or the domain certificate. It is signed by this CA. Got it, guys?
Yeah.
Okay. So this is how you create your own CA, sign your certificates with that CA, add that CA certificate to your browser so that your browser